Welcome. This is Professor Adams, and what we're going to talk about is compound inequalities. When we have an inequality such as, let me write one down, -4 is less than or equal to 5x plus 6 is less than 21. So the first thing you've got to note with a compound inequality, it doesn't matter which direction you're going with the inequality. I could have wrote this as 21 is greater than or equal to 5x plus 6, which is, that should be just strictly greater than, so let me erase that part. There we go, erase that part. Which is greater than or equal to -4. It's still a true statement, and what you're looking for is the fact that you can remove that middle part of the inequality, and the inequality would still hold true. So it doesn't matter which direction as long as it still holds true. So if it holds true, and in this case it does, let me look at this one. -4 is less than or equal to 21, or I could say -4 is less than 21. That still holds true. And if I look at this one, I have 21 is greater than -4, or I have 21 is greater than or equal to -4. That's fine. What isn't fine with a compound inequality is if I would have started out with -4 is less than or equal to 5x plus 6, which is less than 21. Now, if I were to change the direction of the inequality without reordering it, it's probably not going to be a true statement still. And what I mean by that is if I decided that I'm going to rewrite this as -4 is greater than or equal to 5x plus 6 is greater than 21, if I eliminated this middle piece, I can see that this is not true. -4 is not greater than or equal to, or even greater than 21. So you won't change the direction of the inequality arbitrarily. There'd be a reason why you'd want to change the direction. Either you are reordering it, like I did up here. You're either reordering it like I did up here and the inequalities change direction, or you're going to be dividing or multiplying by a negative number, which would then reorder how the numbers are. And what I mean by that is that if you multiplied everything by a negative, negatives would become positive, positive would become negative, and it should hold true. So when you're doing compound inequalities, you got to make sure it holds true if you remove the middle piece. Now, when you're doing a compound inequality, because you can remove the middle piece and it'll still hold true, you can either treat the compound inequality as two separate inequalities. You can say in this case -4 is less than or equal to 5x plus 6, and it also has to hold true that 5x plus 6 has to be less than 21. And you can treat them as two individual inequalities and then bring it back together. So let's do that first. So we subtract 6 from both sides, and this goes to 0, that goes to -10, so -10 is less than or equal to 5x, and I would divide by 5, and I would get, for this side of the inequality, I get -2 is less than or equal to x. I would do the same thing over here, as I go ahead and get the 6 to the other side of the inequality by subtracting 6, that goes to 0, and I have 5x is less than, and then we got 15. I would divide by 5, and this would become 1, and I have x is less than 3. And these are both true. These both have to hold true, so it's an and statement. So when you break it apart, a compound inequality, that is true, and to two individual inequalities, it's an and statement. The left side is true, and the right side has to hold true. So then I can bring it back together. I have -2 is less than or equal to x, and that x comes from here, and it comes from here, and less than 3. Interval notation is -2, and that has to be a squared bracket because it is inclusive. So let me make that a squared bracket. Squared bracket. -2, and it goes to 3, and that would be in interval notation. Set builder notation would be x such that x is, let me start that correctly. With set builder, I like set builder better because in this case it's just a matter of putting this in the right place. So I'd write this as -2 is less than or equal to x, which is less than 3. Now, with compound inequalities, because the middle will hold true, I could do this as one single inequality just as long as I consistently do the same thing to the left side as I do to the middle as I do to the right side. And what I mean by same thing is the same operation. So let's redo this one by doing it all together at once without separating it into two separate inequalities. Okay, so I'm going to subtract 6 from the middle. I'm going to subtract 6 from the left, and I have to remember to subtract 6 from the right. So when I do that, each part of the inequality will get that -6. I'll subtract 6 from each of those. This is -10 is less than or equal to 5x, which is less than 15. Now I'm going to go ahead and divide everything by 5, because I want x by itself. Well, actually, I want x with a coefficient of 1. That becomes 1. And so what I get is I get -2 is less than or equal to x, which is less than 3, which is what I had before. When we get to absolute values in inequalities, then we're going to have to break them apart into two separate equations when we have an absolute value and it's greater than some number. And we'll talk about that in a different video. Thanks for joining me.